So, like I said, this is 2.2. There's only one equation I'm going to write down for this, and it's kind of a specific equation, but it will help you a lot. So this is only true on level ground. Oops. So the whatever is being launched has to begin and land at the same height. Does that make sense to everybody? So it is a magic equation. That's not magic, though. So the equation's delta x equals the negative v squared times the sine of 2 theta over g. And v is the overall initial velocity. So that's the, like, if it's fired at an angle, it's going to be the velocity it's fired at that angle. And theta is the angle it's fired at, and g is negative 9.8. And delta x is how far it goes horizontally. Any questions about that? Okay, consider an escalator at an angle of 45 degrees above the horizontal that moves with a velocity of 1 meters per second. What is the vertical component of the escalator's velocity? We're starting out kind of easy here. So we got escalator's going up at 1 meter per second. That angle is 45 degrees. So we're looking for, it's going to be, we'll call it Vy here. So we're going to use sine, cosine, or tangent to find that. Sine. Sine's a good suggestion. So we're going to say sine 45 equals Vy. So opposite over hypotenuse is 1. And a lot of times I'm going to write this as like just Vy equals sine 45 times 1 meter per second. You guys would be okay if I just skipped like this and just went right to this. It'll make our lives easier. Anyway, so what is Vy, the vertical velocity, equal? Make sure your calculator is in degree mode. Decimal. Yep. And if we're looking at our velocity, we should give that direction up. Any questions on that one? So using her physics superpowers, Kelly jumps at an initial velocity of 35 meters per second. She lands 112.35 meters away from her jumping point at the same height. At what angle did Kelly jump? Without that magic equation, this problem is actually pretty hard, because you have to kind of backtrack and do things with sines and cosines and multiple equations. But with the equation, it's not so bad. So we're going to use delta x equals initial velocity squared, or inverse of that, times sine 2 theta all over g. So what we know here, we know delta x is 112.35 meters equals, she was launched at 35 meters per second. That's squared times, there should be a negative out in front of that, times sine 2 theta all over negative 9.8. You notice the negatives there, so those two cancel out. So we're just going to get to sine 2 theta here. What's sine 2 theta equal to? 60 what? 64? Alright, so now we're going to take the equals 64. Okay. What is it? 8. So not 64. What was it? 0.8988. That makes more sense. So now we take the inverse sine of both sides. So we get 2 theta equals sine to negative 1 of 0.8988. And then what does theta equal when you do that? It's 32 degrees. Any questions on that one? Okay. One thing I want everybody to try real quick is substitute back in with, instead of 32, try doing, what would that be? 58 degrees, and see if you get the same answer. The 58 is a complementary angle, that is correct. So do you get the same distance with using 58? So if you're launching from one height to another height that's the same, complementary angles will give you the same delta x. So there are 2 acceptable answers for this. You don't have to give both. No. Ask Kelly. So projectiles, a 19-meter high cliff. Whee. Angle of 50 degrees, 19 meters per second. And we're looking for delta x. Alright, so in the vertical direction, what do we know? Actually, before we do the vertical and the horizontal, let's break down our velocity into components. So we've got initial velocity is 22 meters per second. And we've got angle is 50 degrees. This side is going to be the initial velocity in the y direction, or the original velocity in the y direction. And this side is going to be the velocity in the x direction. That, because we're not given anything about acceleration, is going to stay constant. So we're going to say VOY. We're going to use sine or cosine for that. So sine 50 times 22 meters per second. What's VOY equal? 16.85 meters per second. And then VX is going to be cosine 50 times 22. And what's Vx equal to? 14.14 meters per second. Alright, so that'll be useful later on. So what do we know in the vertical direction? Garrett. Nope. So VOY equals 16.85 meters per second. What else do we know? Paul.
Delta y equals negative 19 meters.
Delta y equals negative 19 meters. And Garrett, what's the last thing we know? Alright, that's all we know in the vertical direction. What do we know in the horizontal direction? Garrett? So initial velocity, or velocity in the x direction, is 14.14 meters per second, and that'll stay constant throughout. We're looking for delta x, but what do we need to find delta x? Time. So we want to find time. How can we find time? Use the stuff in the vertical to find time. Alright, I'm going to shrink that down a little bit. Alright. So we're going to use equals VOY t plus 1/2 gt squared. Solve for time here. So we get negative 19 equals 16.85 times t plus 1/2 times negative 9.8 times t squared. I would suggest getting the Pythagorean theorem programmed into your calculators because it'll make your life easy because you're going to be doing a lot of equations like this. You can do it in 2 steps. Find final velocity first. Make sure you make its negatives because you're going to be taking the square root of something to get it. But you'll probably make fewer mistakes and save yourself a lot of time if you can just plug this into the quad form on your calculator. So what's our time equal? 4.33 seconds. And the other one was negative, right? So what did you guys get for that? What was it? Negative 0.89 seconds. What this represents, just for your own information, is like if you backtracked, like if the motion was going like it has been, if you went back in negative time, you'd get back to here in 0.89 seconds. Doesn't really do you much good, but that's just what it means. Alright, so now we've got time, so we're going to use Vx equals delta x over t. We got Vx as 14.14 meters per second equals delta x, which is what we're looking for, over our time, which is 4.33 seconds. And what do we get for delta x? 61.3 meters. Any questions on that problem? Polar bears are throwing rocks at Claire with threatening messages attached. The bears stand 1.5 or 5.7 meters away from her window. They throw rocks so that they only have a horizontal velocity when they hit the window. The rocks are moving at 6.65 meters per second when they hit the window. How high is the window? So if we were to draw this out, okay. So let's say the polar bear, we're going to assume the polar bear is throwing it from ground level essentially. So we'll disregard the height of the polar bear. So it throws a rock and it hits the window going just horizontally at 6.65 meters per second. Alright, so how high is the window? Alright, what do we know in the horizontal direction? Yep, so the velocity throughout the flight in the horizontal direction is unchanging, and they hit the window with only a horizontal velocity, so our horizontal velocity is 6.65 meters per second. And we know delta x, we're just assuming the polar bear is negligibly small, which is not a very good assumption, but here. There we go. So delta x is 5.7 meters. Vertically, what do we know? G, they have 9.8 meters per second squared. We know our final velocity is 0. Anything else we know? Nope. So we're looking for delta y. What are we going to need to find? Time. So we're going to find time using the horizontal parts, and then use that horizontal time, which is the same as vertical time, to find delta y. Alright, so to find time, we're going to use Vx equals delta x over t. So we get 6.65 meters per second equals 5.7 meters divided by time. What's time equal? What was it? 0.86 seconds. So that's our time over here. Alright, do we have an equation that has all four of these variables? No. We can do it in one step if you guys want, or we can find the initial velocity and then find delta y.
One step.
Alright, how's the time going to compare, like, how's the velocity right here compared to the velocity it would be if it, like, continued and went right there, the vertical velocity? It'd be the same, opposite. Yes. So we can just say, look at this part and say our initial velocity is 0, and then find final velocity. Or then find delta y using that. We can't use both that our initial and final velocity is 0, though. Do you want me to just do it the other way?
I just wanted to notice. I'm sure I can do it.
We're looking at it when it breaks through the from when it breaks through the window to when it hits the ground.
Yes.
On the other side.
Yeah. So like if we, our vertical velocity right at this point, let me grab my highlighter thing. Our vertical velocity at this point is going to be the opposite of our vertical velocity at this point.
We're finding the opposite of delta y.
So we'll find we don't need this velocity at all, but delta y for this part equals delta y for this part. Yes. So the opposite, we'll find the opposite of delta y for this part, and we'll just make it positive to figure out how high the window was.
No, I like that. We can all do 2 steps.
Okay. We'll do it this way, and I can talk to me individually if you want the other thing. So what we're going to use is delta y equals VOY t plus 1/2 gt squared. So delta y equals, this whole thing will be 0. So our initial velocity in the y direction is going to be 0. Plus 1/2 times negative 9.8 times 0.86 squared. And what do we get for delta y? Negative 3.6 meters. So our window is 3.6 meters tall. Because if on the way back down after it goes through the window in Claire's house, it has one story, I guess. It would have to fall 3.6 meters to get back to the ground. Or you could find the initial velocity using the stuff you had and then find delta y that way. Either way works. Alright, any questions on this one? Paul?
Can we just make like a new equation that like negative delta y equals b f t?
If you'd like to do that, Paul, you are more than welcome to make like the opposite of that equation, essentially.